Okay, this is going to be the last set of problems before we get a little more complex and actually find whether things are maximums or minimums, or maxima minima. I never get it right. Let's take a look at this today and find our critical numbers. How do I find that? Well, I take the derivative and I set it to 0. So the derivative of this is going to be 5x to the fourth minus 3x squared. Always factor, always factor. Like that. That's how we factor that. Well, x squared is going to immediately be an x equals 0. Right? If it's by itself, that's easy. How do I make things 0? I multiply them by 0. So x could be 0 here. And an important thing to note here is that on your graph, let's come back to the main f of x here. It's to the 5th power. So all odd functions are going to look like this. Doesn't really, I guess that one looks the same. 1, 2, 3, another one like that. They're all going to look like that. It's just a matter of how many times they change direction. And they can change direction exactly one time less, that's why this is to the 4th power, than the actual degree of the function. So you see on a cubic function, it changed direction twice, here and here. On a 5th function, it can change direction 4 times like this. But that's not what's happening here, because we have a double x equals 0 here. And whenever you have it doubled up like that, it doesn't change direction. So what this one's going to do, without looking at the graph, I can tell you it's going to come flat like this, and then continue to descend and then go up. So it looks like a cubic function from far away. It would just look like that maybe. But when you look up close, there's going to be a maximum here. There's going to be a minimum here. This is where x equals 0. And you learned that way back in Algebra 2, but I don't know if you're going to have remembered it. So I just want to reiterate that to you. We will go into that in later lessons for finding whether things are maximum or minima. But for now, let's just find the critical values here. 5x squared minus 3 equals 0. And that's all I'm going to ask you for in this lesson, is to find the x values that make the derivative equal to 0, because that is what defines a critical number for a function. So of course we're going to get x equals plus or minus the square root of 3/5 for this. So you can bet that it goes like this, and this is at x equals negative root 3/5, and here it's at positive root 3/5, like that. Guarantee it without looking at the graph. Okay, the next one, that's an interesting looking graph, e to the x plus e to the negative 2x. I'm sure we can see together that ultimately e to the x would go to infinity, so it's going to do something like this. Okay, but what is it exactly? What is exactly our critical number? That's a different question. That's a question for a calculus student or teacher. Take f prime, set it to 0. What's f prime? Well, that's e to the x, and then we have a chain rule here, minus 2e to the negative 2x. Since it's equal to 0, I'm going to add this over, and we'll say e to the x equals 2e to the negative 2x. And I don't want a negative exponent, so let's multiply both sides by e to the 2x like this. And I'm going to get e to the 3x, these cancel, equals 2. Now my x is in the exponent. How do I get rid of that? That's natural log. Natural log. Take the exponent out. You get 3x ln of e equals ln of 2. Natural log of e is equal to 1. There's no mistake there. Divide by 3, and we're going to get x is equal to the natural log of 2 divided by 3. So in this function, that's probably a minima. You're going to have an x value of that right here. And when you plug that into the function, right here, you'll get the y value for that to get the real minima value. And that is what you want to be doing eventually. But for now, we're just practicing finding critical numbers. And you'll find that a lot of these simplify down when you're doing it this way. The next one's a good example of a nightmare, but I'm going to do it anyway. F of x is equal to x root x minus x squared. Sure, let's take the derivative of that and set it to 0, because that's how we find critical numbers. This is a product rule. It's an x function times an x function, u prime v. U prime is 1, so it's just going to be v plus v prime u. That'll be 1/2. This is less fun. X minus x squared to the negative 1/2. You should do it. And then chain rule. It's not just negative 2x. This is still part of it over here, so it's going to be 1 minus 2x, like that. And then times u, so we have another x out here still, like that. So what do we get here? We get the square root is still there. That's good. And what's on top here? It's going to be x minus 2x squared over 2 root x minus x squared, like that. If we want to put these together, because they're going to equal 0, still going to equal 0, then I'm going to multiply top and bottom by this guy here. That should make sense, right? So that'll become 2, and a root times a root is just the inside, so x minus x squared. And then it's going to be plus x minus 2x squared, and that's all going to be over 2 root x minus x squared equals 0. I'm moving kind of fast, but you can always hit pause, can't you? So 2x plus x, that gives me a 3x. That's one that I do expect you to know how to do. And then this is going to distribute to a negative 2x squared, and negative 2x squared, we get negative 4x squared on top, like that. We still have that hideousness on the bottom. But I have good news. Critical numbers are easy, because anything in the numerator that's equal to 0 will create a critical number, will match 0, right? So we can almost ignore the denominator, but for the domain to make sure that it's okay. So I'll say 3x minus 4x squared equals 0. And we factor. Every single problem we factor. Have to factor. So again, we see that x equals 0 is going to be a critical number. That's very common. And on this one, 3 minus 4x equals 0. Okay, so add the 4x over, and what do you get? X equals 3/4. So here's our two critical numbers for this problem. When you take that x value, plug it into the formula here, you get the y value of exactly where that critical point is. And that's all you really want to do with this lesson. We'll go into using it more in a little bit, but that's it so far for this particular problem set. We have one more problem to do. It's a little bit trig, but it's not bad. F of x equals x minus 2 cosine of x. Okay, how would you take the derivative of this? This one won't be so bad. We just need to take the derivative and set it to 0. Well, it's going to be 1. And it looks like it's going to be plus 2 sine x. I'm sure you remember the derivative of cosine is a negative sign. So if I set that to 0, then that means sine of x is going to equal negative 1/2. So let's look at the unit circle real quick. Negative 1/2 is here. So that's going to be 11 pi over 6. Just 1/6 of a pi shy of 2 pi. It's going to be 1/6 of a pi more than a pi, so that's going to be 7 pi over 6. So here's our two critical values for x in this function. And I would just plug those in right here, 11 pi over 6 or whatever, and find my y values. And that would be where you would find your maximum and minimum. So in the next video series, we'll actually do an explainer and show how to use a second derivative to determine if it's a maximum or if it's a minimum or neither. And that'll be cool. So I'll see you in number 5.